What do we have here? Is this a thing for the thing? Guys, welcome back to Kitchen Chronicles with Arthur K. Today we're going to give you a couple top tips on how to purchase an Lexus GS450h inverter and what to look for. Okay, so on our test table here, we have a sample specimen. The eagle-eyed amongst you may notice, what is that, Arthur? What could you point out to us?
I could point out that the missing high voltage wire.
Very good. And now the reason I purchased this thing, let me do a 360 here. So I purchased this inverter because it came with the inverter plug, be it butchered. Today, Arthur will demonstrate how to remove the high voltage cables, and also we may actually gut this inverter and show you how to remove the DC-DC out of it, and maybe how to do a bypass for the battery connection on the side there. This video brought to you by WD-40, which we know is not a lubricant, nor is it a cutting oil for when you're drilling, but it sure helps to get these high voltage cables out. So we will see Arthur K here demonstrate how to pry them out properly. You need to be patient, give it a little bit of WD-40, and they don't have to be cut the way they're cut. So if anybody at a wrecking yard is watching this, you can make a bit more money if you properly extrude those. Arthur, do you want to give it a shot and show us how you work one out of there?
Yeah, exactly. So just as Greg mentioned, you want to spray the seals with WD-40 to make them easy to come out. These are really not very easy to pull. So anything you can do to help with it goes a long way. So WD-40 is really excellent tool. So basically you want to spray around those seals, and you want to wait a few minutes for that, for the WD-40 to penetrate. I mean, keep in mind this is nice soft rubber, so it's not gonna penetrate this immediately, but after a couple of minutes it will definitely do the job. And here we have a situation where those cables were cut just so short that really it's hard kind of to pull on those. So we're gonna have to pry gently with the flat screwdriver. I already started working on this, and you can see it's coming out nicely. There's a very likely, if you are not careful, you may crack those. But so far, I'm doing fairly well. You want to do it like a little bit on each side, and you see, okay, yeah, we got it. We got that
Beautiful.
one. Oh, what a surprise, Greg. So not only is missing cable, but it's missing
a tooth.
Yeah.
Wow, guys. So yeah, you noobs watching, this is supposed to be 3-phase. So how are they like labeled like XYZ or W something?
Yeah.
They're supposed to be 3 orange cables, wires, basically, not 2.
Yeah, so here if you do close up, Greg, we can already see that someone was on it before, and they basically chipped a piece of the connector. So
and don't think it was the Greg, guys. This happened before. You should have seen the box this arrived in. So yeah, okay. We didn't have high hopes for this inverter. Basically bought the inverter for the plug.
So you want to do close up here while I'm praying this out, and you want to just do little by little on each side. Very, very careful. Doesn't guarantee it's not gonna crack, but there's less chance for this to happen. And you can
definitely we recommend doing this on a kitchen table.
Yes, absolutely. It already came out a little bit.
Yeah, so this was not pre-staged or anything. This is happening on real live TV here.
Yeah, and you can see editing. This out already a little bit.
And it's important, guys. We're having fun with this, but you don't want to damage these cables. You want to preserve them. And those rubber O-rings in there, 10, 15 years, we'll get them sealed. But a little bit of a liberation juice, and it will come out.
Okay, can you hear some noises?
It's the last time you'll accuse Arthur of just being a software engineer.
Yeah.
This is hands-on, baby.
Okay, we got it.
He's just trying to earn his room and board. Good job, Arthur. Nicely done.
And this one is not missing the tooth.
Yeah, let's take a look. See, this is a 3-tooth animal.
Version.
Yeah. Very nice. Okay, we'll be back and move on to the next step. You want to point out something in there?
Yeah, just close up for what the internal connector looks like.
Yeah.
Yeah.
Very nice. Okay. Okay, guys, moving right along. You may buy an inverter or find it in the field with these two side connectors on it. So the one that Arthur's pointing out, comes from the traction battery, and this is the input. And the one next to it is for AC. To remove these, you're going to have to remove the top plate here, the cover. So why don't you do that first? I think it's a 10 mil. And this first one, it's a long bolt, and it actually screws through the AC connector, okay? See if you can unplug that AC connector, and there should be a white clip on the side, perhaps. There you go. Okay, why don't you screw that bolt into the connector, actually. See how it drops through it? And that is threaded. So you will not, in the field, if you're frustrated in the junkyard trying to pull an inverter, unless you undo that bolt, which screws into the connector, you won't be able to unplug it. Good job. Now, to get the battery one, we actually lift that cover.
We need Phillips for that, unfortunately.
Oh, there's an additional screw. I did not know there was a little screw there.
How about that?
Yep. And then in here, oh, this is interesting. I think there's a fuse.
Yeah.
I think what you unscrewed actually supposed to lift up.
Yeah, that's right.
Let's try it.
But it depends what you want to
Yeah.
accomplish, right? Because you are not necessarily after the fuse. You basically, your objective may be just simply disconnect it, right? So for that, it's easier.
But I think this is like a safety, like what is it called when like the Nissan Leaf has that fuse thing that you disengage? No, it's not that.
Toyota has a safety disconnect at the traction battery.
Okay.
Yeah.
Okay, so we're gonna go for it and undo the 10 mil. And then this one is long as well, and this one goes through the plug for the traction battery. So we're gonna unplug it. And there you go. Let's screw this one in there too to demonstrate that it is threaded, and that's what holds it on. So there you go. Nice little pair. Again, wish these weren't cut. Maybe they're cut just to expedite the extraction of the inverters, but really it's just, 2 minutes tops to undo those bolts and nicely unplug them. But now we have it. Now, just as a reminder, guys, when you do EV conversions, we do not plug the battery pack into here. We bypass this input and we remove this plate, and we will plug it right into the main bus bars or the main bus. I think we're going to continue with this inverter and take the lid off of it, take a peek inside, and I want to see how we can gut it and maybe use it as a junction box. So we'll be back in a second. And go ahead.
Okay, so if you really want to get to the little fuse that is there, you basically lift this cover gently, wiggle it a little bit, and so this exposes the fuse, and also this cover serves as a high voltage interlock.
Very nice. Yeah, so we can leave that Phillips screw in the lid if you want to disconnect the interlock, but either way, you remove the lid to do the plugs underneath it. Very nice. Okay, guys, we're going to move on and maybe take a lid off of this. I know that a lot of this has been done by Damien, but it doesn't hurt to have more videos in the EV conversion community to help the noobs, new guys to the sport. So we're having fun. We're going to keep going. Okay, guys, so moving along. what I'm tempted to do is remove this lid to give you a peek inside a Lexus GS450h inverter. And at the same time, I want to ask Arthur a safety question here, because an inverter has a big capacitor in it. I'm going to hand the mic over to him, have explain like, when is it safe to dig into this inverter? Do you have to wait a while? Is it dangerous? Because there is a big cap in there. So here you go, Arthur. Tell us a little bit about that. Like, what safety tips would you recommend? Is it just safe to dig into it once the battery is disconnected, or what?
Yeah, sure. I mean, we got this pretty big capacitor here, and it definitely holds charge for a little bit, but the chances are that when you get to the vehicle, it has been disconnected for a very long time. So when you source this inverter, there's really no way that this will pose any danger. But if you are working on a project, let's say a bench setup, and you're connecting, testing it, and then you disconnect, and you definitely need to wait a little bit. And uh, the safest way would be measure the voltage on the post where you connect your battery. Once you disconnect, just hook up your voltmeter and see the voltage dropping. And when it drops, ideally below 24 volts, it will be safe for you to work on that.
Okay, so we're gonna thank you, Arthur. So we're gonna continue on and take a lid off of it, and we have a couple goals here. Aside from just showing you the guts again of what's inside this inverter, um, there have been people who've gutted it and removed the DC-DC converter out of it, maybe use it as a junction box. We also are tempted, or I'm tempted, to see if we can figure out how to use the OEM battery input and bypass internally whatever needs to be bypassed to tap into the main bus. So we'll see if that's possible, if the connection will support the higher amps, and just have some fun doing this. But the lid is probably glued on here, so we're going to get started and maybe come back later, use a heat gun, and see if we can break that seal. So here's Arthur with the impact gun. Those were pretty hard on there, but to do by hand, right?
Exactly. This one is pretty hard.
Looks like maybe 10 screws.
Yep, something around that.
Oh, wow.
Easy.
So that wasn't stuck on there at all. This is to our surprise, right?
Yes, exactly. Because
do you think it may have been removed in the past?
It is possible. It definitely they use silicone as a seal, so it's basically glue on. But this one came off really surprisingly easily. So
Okay, let me get in here and give you a bird's eye view of it. Arthur, why don't you take the mic, point out some components to us just that jump out at you. What do we got here? What's obvious? Is this the logic board right here?
no, this is the part of the DC-DC converter.
Okay.
Circuit board.
And what are these big black boxes?
So we have a capacitor here, and we have also IGBTs here for controlling the for the power stage of the DC-DC converter.
So these components will be coming out if we are not going to use DC-DC. And why don't we use the OEM DC-DC in a Lexus GS450h inverter? I mean, it worked as a DC-DC in the actual Lexus, so why don't we use it in an EV conversion?
Yeah, the reason, well, we can still use it in our DC-DC conversion, but not in the same way as it was originally designed. So the original idea behind it was because traction battery for Lexus was only 200, I believe, 80 volt or something around that. And in order to provide better performance at a higher speed, they used this DC-DC converter to step up the voltage to all the way up to 600 volt. But power was limited, so basically this DC-DC inverter wouldn't be powerful enough to provide enough power for traction only on the electric motor. So we have to keep in mind that this was sort of additional uh, electric support to the ICE motor in there. So it didn't require as much power, but in our conversion, when we use it exclusively on electric, then this is nowhere nearly enough. There are some other uses for this DC inverter, the converter, but that would be out of scope of this video.
Got it. Thank you, sir. We both agreed that we're going to start gutting the DC-DC out of it. Arthur pointed out that some of these things are sort of molded into this case, and we'll see how much we can get out, and then we'll reach heat sink or a cooling passages. So we're going after the green circuit board here, which is the DC-DC circuit board, logic board, I think it's called. And we're going to see what we can remove.
So we want to get to the connections, right? That's one reason why we remove.
Yes, those orange or brownish bus bars there is what we want to get at, and see if we can internally bypass or reach the main bus system to then use the OEM connection here to plug in, and whether that's a wise choice or not. Okay. Okay. Anything can come out now?
No, not ready yet.
Okay. What can we?
No, it needs a little bit more work.
Okay.
Not to avoid damaging any of the components.
Okay.
Because we got the soldered connection here.
Oh, that. So that has to be like loosened up with solder, yeah?
Potentially.
Okay. Can anything be unplugged here?
Yeah, we could probably pull out the capacitor.
Let's go after it.
Here.
I did buy this inverter for its inverter plug. It's low voltage plug there. So everything is par for the course. Okay.
Yeah, that's not gonna come out easily.
I'm disappointed. I'm disappointed. Like, what about, there's a screw right there. Can anything lift up if we loosen that guy?
I don't think so.
I mean, we need a money shot here. Something's got to come out.
That won't be enough to pull anything out. I mean, and there's a bus bars going on over here. Yeah, it needs a little bit more work.
So guys, I want to introduce this segment, and I just want to point out that what Arthur has accomplished here is nothing short of a miracle. He is working basically with limited tools, a cattle prod, some duct tape, and a tire iron. And this man, with limited resources, has literally liberated the circuit board. Now, if I'm serious for a minute, we use 2 soldering irons here and 4 hands, and you have to desolder, I believe. How many pins is that?
It's 12 pin tool. They're in group of 4 and 2, so 12 pins, and ideally you want to heat them up all at the same time. But how do you do with those just simple soldering irons? We use some tricks. We actually use the copper wire to bridge those clusters of pins, and we were kind of working together on with those 2 irons, one on each side, and just uh, uh, basically heating up those pins and gently lifting up the board until we were able to free that board from this IGBT assembly that is hidden underneath. So this is like the logic and the IGBT drivers, and here underneath what we have is this IGBT module. So the reason why we had to do this is because we need to take out this board to expose those bolts here and all those bus bars, because that's the only way this is coming off.
Yes, guys. So as Arthur pointed out, I would have been a barbarian and gotten nowhere because the circuit board has to be removed. So he encouraged me to exhibit a little bit of patience, did a great job of removing those, unsoldering them. And now we're going to show you the next step. We hope to just remove this for fun. We know we're not the first nor the last. Doesn't hurt to have more videos out there for EV conversions, help people out. So we're just going to keep going and see what happens when you remove this, what mostly is unused DC-DC converter when it comes to Lexus GS450h conversions, as we rely on DC-DC from a standalone unit or something integrated with a battery charger. Is that correct?
Yeah.
All right, guys. So stay tuned. We're going to undo some screws now. Okay, go for it.
Give it a go.
Do it. One bus bar. And these bus bars are coming off of IGBTs?
Yes, IGBT module.
What is an IGBT?
Oh, these are special kind of power transistors that can make this magic work for us. Basically, switch the really high current, high voltage, fast speed to generate basically the proper 3-phase sine wave for us.
They are on there, aren't they?
Yep. Impact is very helpful here. Pretty fancy bus bar assembly.
That is
here.
impressive, isn't it?
Yeah.
What do we got there?
So we got a little capacitor here.
Little cap for
Yep.
DC-DC cap, right?
Well, yeah. It's the smaller one. And then here we have the bigger one. This come out almost. Feels like there is another bolt holding it.
Sure does, doesn't it?
Okay, I got it right there. Okay.
Look at that.
Almost out.
That is a hefty cap. It's pretty deep in there.
Yep.
Okay. Does that thing have any specs on it?
Yeah, it does.
What does it?
So this is, you can show close up. It is 500 volt, 378 microfarads. Obviously Panasonic.
Mm-hmm.
Yeah, so
We're getting there, guys.
finding some space.
We have some real estate. As I shove Arthur out of the way to bring you this bird's eye view, ladies and gentlemen.
So yeah, we can also say that here we got this big inductor, which is potted, and it's obviously part of this whole assembly, and that's not coming out anywhere really.
It's like molded.
It's molded almost. Yeah,
that's okay.
Yeah,
but we can
free up this space here very easily.
So what is this black box here now?
Yeah, that's the IGBT module.
Okay, and Arthur pointed out something very important. Point to the 4 posts sticking up. That these are actually, they're threaded in there. So
exactly. I can try to remove them live on camera. So that's basically the reason why we had to remove that circuit board, right? Because it was covering these. There was no way to access these standoffs or however.
Good call. I think that is some sort of standoff.
It serves more than one purpose, obviously, because it's basically holding this assembly to the cooling plate, right? Because what we have here, what we expose here, this is our cooling plate.
3-inch drop in there. That's about 3 inches deep. So
something like that.
Yeah. It could be utilized for a junction box of sorts.
Okay. Yeah, exactly. Some thermal compound to help with the heat transfer between the heatsink and the IGBT module.
Very nice. I'm sure that's
so
a hefty
now
sound
it
for
looks
that.
even better.
Freer, yeah. Can we go further? Not sure if we can remove.
Well, we got this extra resistor here.
Oh yeah, we'll go after that guy.
It's not gonna free up too much space, but just
it's
a
worth
little
it,
bit more. Yeah.
So maybe do those drop to the main bus bar there?
Yeah, they do. So these certainly could be used to power some accessories and sort of like a junction box that could be arranged here to power accessories.
But you wouldn't say those would work to power my truck?
Yeah, they wouldn't do that.
Would it be worth me trying?
If you want to create some magic smoke, yeah, it would be worth it.
Really? You would not suggest I try that?
Correct.
Oh boy, I think I'm gonna try it. Okay, let's keep going. Let's get that resistor out. See if I have a spec on that guy.
Yeah. It has some part number, but I don't see. No, honestly, I don't see spec.
Yeah.
Maybe it is hidden underneath of that, but
It almost
Other
looks
than that,
heftier than the one in the
yeah,
BMW
it looks
safety box.
pretty hefty and great quality, obviously. But we only have this part number, so
Okay.
it'll be hard to say
Okay,
right
that's
now
fair
what the
enough.
specification is.
We're getting, and then this one has, there's some aluminum casting molding that kind of stands up there where it went. So I don't know if you would want to like grind it. So below this floor here, that's where we have the coolant passage. This coolant passage goes there, just so you guys know. And I don't know where it comes out on the other side. There it is. So it flows under that. And my kind of idea was to see if we can use these bus bars to feed the battery, the traction battery power right into the inverter where it went OEM-ishly.
Yeah, but
So,
unfortunately, it doesn't look like we're possible because they're severely undersized. But as I mentioned, there is a possibility to use them for some accessories.
or replace them altogether with heftier bus bars.
Possibly, but that would be, I think, challenging because there is limited space and you would need to have them isolated properly.
So here's a question for you. If we were to take off this plastic cover, that's what would reach these guys, right? That's essentially what they're doing, right? I think they're bolted on.
They're bolted on, yeah.
Why don't we do that? I want to remove that black plastic here to confirm that that's what ties into these. Anything else we can take out from the top? Like, can we remove those bus bars there?
No, not really, because they're permanently attached by those weldings here.
Okay.
Yeah, without going medieval, unfortunately, no way. But there's also no reason really to remove them because you're not
Doesn't
gonna
gain us
really
much. Yeah.
exactly to use that space for anything.
And maybe if we open the other side of the inverter, the bottom, maybe we can unplug these on the other end to get those out. I can see that there's something running here.
Most likely temperature sensor for the
There you go.
inductor.
So we're going to remove this plastic thing. I'll bust out my heat gun here and put some heat on it, and I know this gently pries off, and then we can see some bolts there. And I wonder if that's what in turn frees these up. Let me ask you a question about this other end. Is this flimsy? Is this connector too flimsy then to bring in, the 360 volts from the BMW battery pack and whatever amps we're going to pull, 200 amps or whatever it pulls?
Again, you could actually use this to power some accessories, but as far as the traction, no, it's severely undersized because this inverter will draw roughly up to 500.
I'm serious. We may need to use a box cutting knife to kind of hammer in from the side, unless you can start wedging that screwdriver in there gently.
So I could seriously use the third hand. So what I will do is I will hold camera and I will allow drag to get on this cover and work this.
Yeah.
Do you want to feel the temperature and give me some feedback, or do you need more heat? Or
It's getting there, but I know that this was really kind of tough to start, and then once you get in there, and it's not like I'm gonna be putting this plastic back in there, but it just takes. Yeah, it's getting there. It is getting there. I can feel it on my arm. So. She's stubborn. There it is. There it is. Oh, trying to.
do you want to use screwdriver now?
It's hard to get in there.
But you made the part.
Yeah.
So yeah, now it's easier to.
I'm trying to work it there. Just follow my blade. Do you see like where I'm reaching?
Sure. Just worry about melting this piece.
We're just trying to make Professor Kelly proud here, okay? That's all we're doing. It's coming. It's actually pretty good.
Even that this cap will never go back here again, I would still
We
like to preserve it. All right, we're getting somewhere.
So step 3 of EV conversions: make friends so that you can have extra arms. Look at that, guys. Easy peasy. Okay. Put that down. All right, so we'll undo those two bolts there and see where it takes us. Let me set this down. Anybody see my glasses?
Over there.
These are my bifocals. Okay, guys. Ha! How the roles have turned. I get to finally work my impact. I waited all day for this, guys. Hey, check it out. Make sure we get this piece de resistance.
Oh my God.
This is hefty, dude.
I would not necessarily call this hefty.
So one is a little bit skinnier than the other. But yeah, it's really interesting. I think this is fine. I don't know. I think this is copper but plated in something. What would you say?
I think so. Yeah,
Yeah.
at the very minimum, you would have to come up with some heavy-duty custom bus bars that would fit in the same space. It would be kind of tricky. Not impossible, but kind of tricky.
And then, can we get this on camera?
Mm-hmm.
So that's where it bolts down. So you could do something. All you need to do is kind of fab something up, a little bit bulkier, heftier. And then my concern was, is this plug internally making enough of a connection? And you keep saying 1,000 times that it's good for accessories and nothing more. So maybe, I don't know, would you want to pull the battery charger off of this? Like maybe use the AC connection for a battery charger?
Yeah, absolutely. Or the other one.
Or this one? Yeah, so the idea is that we would try to use this as a junction box, right? So you bring in the battery power on here to the main bus bar, and then you keep the stock bus bar here, and then from here you're using this as a junction block if you need to for your DC-DC if it's separate box, or for the battery charger if it's a separate box, something to that effect. Let me ask you this, Arthur. Would it be silly to build up your contactor box here, like the guts of a safety box in here? I know you want that as close to the battery as possible because you risk having live wires coming into here, and then your current shunt living in here, your positive contactor, negative contactor, pre-charge circuit. Would that be a silly move, or could that work?
I don't think it would be a silly move. I see this as a possibility. It is a little bit less room than I would like. It kind of depends what components you use, but those contactors are usually quite large, and arranging anything here in this limited space may be a little bit difficult. But I would say it's not out of the question. It's a possibility.
Okay, we're going to see if you have enough time to flip this thing upside down, remove the other side, because I am tempted to nicely unplug these wires. But I thanks guys for following along so far. We'll keep going a little bit, hoping you're finding this entertaining, useful, and yeah, let's keep going.